October the 29th, 2018, Java Sea, Indonesia. Lion Air Flight 610 climbs from Jakarta. 13 minutes later, all 189 people on board are dead. March the 10th, 2019, Addis Ababa, Ethiopia. Ethiopian Airlines Flight 302 takes off. 6 minutes later, 157 lives end. 2 modern passenger jets, same aircraft model, same system failure, same result. Official explanations focused on pilot error and procedure. Investigators blamed insufficient training. Airlines pointed to maintenance issues. But this was not a pilot error story. It was a story of design, regulation, and corporate decision-making. How did one of the most trusted engineering companies in the world build a plane that could override its own pilots? Boeing didn't start as a company that cut corners. For decades, it had an engineering-first culture. Safety wasn't a marketing slogan. It was the foundation of everything. The 747 took its first flight just 930 days after Boeing decided to build it. Engineers led. Executives followed. The company existed to build aircraft, not to maximize quarterly earnings. As recently as 2000, one journalist wrote, "Boeing has always been less a business than an association of engineers devoted to building amazing flying machines." But that culture died slowly. In 1997, Boeing acquired McDonnell Douglas. The merger was presented as a consolidation. In reality, it was a cultural takeover. McDonnell Douglas brought a finance-driven mentality. Cost-cutting replaced innovation. Risk aversion became a doctrine. Decision-making power shifted from Seattle engineers to Chicago executives. Insiders still joke, McDonnell Douglas bought Boeing with Boeing's money. In 2005, Boeing hired its first CEO without prior experience in aircraft engineering. The company moved its headquarters from Seattle to Chicago, placing executives 2,000 miles away from the engineers who built the planes. By the time the 737 MAX program began, Boeing no longer behaved like old Boeing. In 2010, Airbus launched the A320neo. It promised 15% better fuel efficiency with minimal retraining for pilots. Airlines loved it. Orders poured in. Boeing faced a choice: build a new aircraft from scratch or redesign the existing 737. A new aircraft would take a decade and cost billions. It would require pilots to undergo expensive simulator training, which airlines wanted to avoid. Boeing chose speed. It would update the 737 instead of replacing it. The decision came with constraints imposed before engineering even began. Don't change the aircraft so much that pilots need simulator training. Finish quickly, keep costs down. The problem wasn't speed. It was what speed made impossible. The 737 was designed in 1967 when fuel was cheap and engines were small. It sat low to the ground for easy maintenance at rural airports. The MAX needed larger, more fuel-efficient engines. But those engines wouldn't fit in the traditional position under the wings. Boeing moved them forward and upward. This solved the clearance problem, but created a new one. The repositioned engines changed the aircraft's aerodynamics. During certain maneuvers, they pushed the nose upward, increasing the risk of a stall. Boeing's solution was software. The Maneuvering Characteristics Augmentation System, or MCAS, was designed to automatically push the nose down when sensors detected a dangerous angle. MCAS was meant to make the MAX handle like older 737s. pilots wouldn't notice the difference. Training requirements would stay minimal. But the system had critical flaws. Single sensor dependency. MCAS relied on one angle of attack sensor. If that sensor failed, MCAS would activate based on false data. Powerful authority. MCAS could move the horizontal stabilizer repeatedly, overriding pilot input. Limited disclosure. Boeing removed references to MCAS from pilot manuals. Most pilots didn't know it existed. This is where the disaster became structurally inevitable. The problems with MCAS didn't emerge suddenly. Engineers knew. During development, Boeing's own test pilots raised concerns about the system's behavior. In simulator tests, they found MCAS would activate aggressively and repeatedly. In 2016, Mark Faulkner, Boeing's chief technical pilot, sent a message to a colleague expressing concern about MCAS. He later told regulators the system was limited in scope and would rarely activate. Internal emails tell a different story. In one message, Faulkner wrote that he had basically lied to the regulators about MCAS without realizing the system had been redesigned to be far more powerful. Years later, Faulkner was indicted for fraud over these communications. In March 2022, he was acquitted. The case illustrated the difficulty of assigning individual criminal responsibility in complex institutional failures. Boeing employees weren't the only ones with doubts. Some international regulators questioned the single sensor design. They asked why MCAS didn't require input from both angle of attack sensors. Boeing's answer? Redundancy wasn't necessary. The system was safe. After the Lion Air crash in October 2018, Boeing conducted internal simulator tests. The results were alarming. Test pilots found that when MCAS was activated due to faulty sensor data, they had fewer than 40 seconds to diagnose the problem and disable the system. After that, the aircraft entered an unrecoverable dive. Boeing shared this information internally, but didn't ground the fleet. Instead, the company issued a bulletin reminding pilots of the runaway stabilizer procedure. The bulletin described the problem vaguely. It didn't mention MCAS by name until the pilots demanded more information. In December 2018, the FAA conducted its own risk assessment using Boeing's data. Concluded that if MCAS wasn't redesigned, it could cause 15 fatal crashes over the aircraft's 30-year lifespan, with projections of nearly 3,000 deaths. Boeing said it would fix the software by April 2019. The FAA accepted the timeline. The Ethiopian crash happened in March, before the fix was implemented. These weren't unknown risks. They were calculated ones. Engineers raised alarms. Simulators showed the danger. Risk assessments quantified the threat. At every stage, evidence suggests the warnings were acknowledged, then minimized. The question wasn't whether Boeing knew. The question was why knowing wasn't enough. Boeing designed the MAX to avoid triggering the need for simulator training. Simulator time was expensive. Airlines didn't want to pay for it. So Boeing minimized differences between the MAX and the older 737 models. Pilots transitioned to the MAX with an iPad course lasting a few hours. MCAS was barely mentioned. The system was described as a background feature, not something pilots needed to manage. The assumption? MCAS would never malfunction. The reality? When it did, pilots faced an invisible adversary. MCAS activated without warning. It pushed the nose down. Pilots pulled it back up. MCAS activated again, the cycle repeated. In simulator tests conducted after the crashes, pilots had less than 40 seconds to diagnose and disable the system before the aircraft entered an unrecoverable dive. Automation had authority. Humans lacked information. The Federal Aviation Administration didn't catch the problem. Why? Because the FAA had delegated much of the MAX certification process to Boeing itself. Under the Organization Designation Authorization Program, Boeing employees acted as FAA representatives. They approved their own designs. This wasn't corruption. It was policy. The FAA lacked resources to certify every component of every aircraft. The industry had grown too complex. But the system depended on trust. Internal documents later revealed how Boeing leveraged that trust. In March 2016, Boeing redesigned MCAS to give it more authority. Hours later, Boeing requested that the FAA remove references to MCAS from the Flight Crew Operations Manual. The FAA approved. The officials who made that decision didn't know about the redesign until after the Lion Air crash. Warning signs were flagged, then diluted. What should have been substantive oversight became procedural. In December 2018, after the Lion Air crash, an internal FAA analysis predicted MCAS could cause 15 fatal crashes over the aircraft's lifespan. Boeing said it would fix the software by April 2019. The Ethiopian crash happened in March. Regulation didn't fail loudly. It failed quietly. Lion Air Flight 610, October 29, 2018. The aircraft took off from Jakarta at 6:20 a.m. Almost immediately, the angle of attack sensor on the captain's side sent false data. MCAS activated. The nose pitched down. The pilots pulled it back up using electric trim switches. MCAS activated again, and again, and again. The pilots disabled the electric trim system following the runway stabilizer procedure. But at high speed, the manual trim wheel was nearly impossible to turn. They re-enabled the electric trim to regain control. MCAS reactivated immediately. The aircraft dove into the Java Sea at over 450 miles per hour. All 189 people on board died. Ethiopian Airlines Flight 302, March 10, 2019. The flight departed Addis Ababa at 8:38 a.m. Within minutes, the same sequence began. False angle of attack data, MCAS activation, pilots fighting the system. These pilots had been briefed on the Lion Air crash. They knew about MCAS. They followed the recommended procedure. They disabled the electric trim. They attempted to use the manual trim wheel. It didn't work. MCAS had already moved the stabilizer too far. The aerodynamic forces were too strong. They re-enabled the electric trim. MCAS was reactivated. The aircraft entered a dive. At 8:44 a.m., it crashed into a field near Bishoftu. All 157 people on board died. The crashes were near identical. The outcome was inevitable. On March 10, 2019, Ethiopia grounded the MAX. China followed on March 11th. The FAA initially defended the aircraft. On March the 11th, it issued a continued airworthiness notice, affirming the MAX was safe to fly. By March 13th, 51 countries had grounded the MAX. The FAA was isolated. That afternoon, facing domestic and international pressure, the FAA reversed course and grounded the aircraft. By March 18th, all 387 MAX aircraft in service worldwide were grounded. The grounding lasted 20 months, the longest in US aviation history. Boeing's initial response was defensive. CEO Dennis Muilenburg called President Trump to reassure him that the aircraft was safe. In public statements, Boeing suggested pilot error and inadequate training contributed to the crashes. Gradually, the truth emerged. In April 2019, Boeing admitted MCAS had activated in both crashes due to faulty sensor data. In June 2020, a Department of Justice Inspector General report revealed Boeing had known about MCAS problems years before the crashes. In September 2020, a House of Representatives investigation concluded Boeing had prioritized profit over safety, and the FAA had failed in its oversight role. Boeing took years to say what engineers already knew. In January 2021, Boeing settled with the Department of Justice. The company agreed to pay $2.5 billion. $243.6 million in criminal fines, $1.77 billion in compensation to airlines, $500 million to families of crash victims. No executives were charged. No individuals went to prison. Dennis Muilenburg, Boeing's CEO during the crashes, was fired in December 2019. He left with $62 million in compensation. Mark Faulkner, Boeing's chief technical pilot, was indicted for fraud over his communications with regulators about MCAS. In March 2022, he was acquitted. Families of crash victims called the settlement a sweetheart deal. In October 2022, a Texas court ruled that victims were legally considered crime victims, which opened the door to additional legal claims. Financial penalties were paid, but personal responsibility was absent. The system that produced the MAX remained largely intact. The MAX disaster wasn't unique. It was precedent. It revealed fundamental tensions in modern aviation. Automation versus human authority. MCAS had the power to override pilots. Pilots didn't have the information to override MCAS. Cost efficiency versus safety margins. Boeing designed the MAX to avoid simulator training costs. That decision killed 346 people. Corporate incentives inside critical infrastructure. Boeing executives prioritized speed and profit. Regulators trusted them to police themselves. These tensions exist across industries: autonomous vehicles, medical devices, financial systems. When engineering answers to finance, catastrophe becomes a rounding error. The 737 MAX returned to service in December 2020. Airlines resumed flights. Passengers boarded. The aircraft is now one of the most common in the sky. Boeing made changes. MCAS now requires input from 2 sensors, not 1. It can only activate once. Pilots can override it more easily. Simulator training is now mandatory. But the culture that produced the MAX, that remains. In January 2024, a door plug blew out of an Alaska Airlines 737 MAX 9 mid-flight. The aircraft depressurized. Passengers were injured. The fuselage was breached. Investigators found loose bolts in multiple MAX 9 aircraft. This wasn't a flight control software issue. It was a production quality control failure, revealing systemic problems in Boeing's manufacturing discipline. Boeing is still cutting costs, still outsourcing, still prioritizing delivery schedules over engineering rigor. Safety failures are rarely accidents. They are the logical outcome of institutional decisions made years earlier. The 737 MAX proved something dangerous. In aviation, you can fail upward. You can kill hundreds of people and remain profitable. The question isn't whether it will happen again. The question is when.